All right, next question. We are going to do a related rates cone question. So a water tank is built in the shape of a cone. The cone has a height of 5 meters. So the height of the cone is 5 meters and the radius of 6 meters. Water is being poured into the tank at a rate of 1.6 meters cubed per minute. So because I see the cubed, I know this means that dV dt is 1.6 meters cubed per minute. At what rate is the water level rising? So what I'm looking for is what rate is the water level rising. So what I'm looking for is dH dt. Okay? When the water is 2 meters deep. So when H equals 2 meters. Okay? So that's all the information that I have and what I'm looking for. So I was given dV dt. I'm looking for dH dt when H is 2. Next, I need a formula. So obviously I need a formula that involves volume and height. So the volume for a cone is 1/3 pi r squared h. Now, we have an issue. So the issue is that I don't have any information about r, nor am I asked to find r. So I have like extra information. I almost need to get rid of him. Whenever this happens, you also need to say to yourself, could dr dt be 0? Because if it's 0, then we can deal with it. But if it's not, we can't. Could dr dt be 0? So basically looking at here, will the radius of the water level be constant? If it's constant, then dr dt is 0. And the answer is no, it's not going to be constant because it's going to change as we go up. Look at the radius is changing. So that's the process I want you to go through mentally when you come across something you don't have the information for. Could dr dt be 0? Okay? And the answer is no. What you need to do is form a ratio. We basically want to get rid of r. Well, if we look here, this is h and this is r. So I can say, and I want to get rid of r, so I can say that r over h equals 6/5. So then I can say that r equals 6/5h. And what I'm going to do is I'm going to plug this guy in here. This ratio strategy will only work if r and h are changing, okay? So I'm going to simplify the equation first, and then I am going to find the derivative. So 6/5h squared, that's going to be 36h squared over 25, but then I have a third here, so it's going to be 36 pi h cubed over 75, because there is an h here. Okay, so now that I have that, now I apply ddt to both sides. So if I apply ddt to both sides, I get dv dt equals, this whole thing is just a coefficient. So it's 36 pi over 75 times 3h squared dh dt. Okay, good, you can still see that. So then what I need to do is solve for what I'm looking for. So I'm looking for dH dt, so I'm going to plug in everything I know. I know dV dt is 1.6. Remember, this is just coefficient. H is 2, so h squared is 4 times 3, so that's going to be a 12 times dH dt. And I do all kinds of rearranging, and I end up with 5/18 pi meters per minute is what dH dt equals. And remember, I would need to write a sentence. So the height, always tell me what's changing, is increasing. Tell me whether it's increasing or decreasing at a rate of 5/18 pi meters per minute. So that is how you do a cone question. What I really want you guys to get from that is, what do I do when I have an extra variable and the rate of change of that variable is not 0?